This is Mr. Anderson for Kellogg Community College. We are doing Section 3 of Chapter 8. We're studying solutions of quadratic equations. And what we learned in the last section in video for Section 8, or Section 8.2, we learned the quadratic formula is... Oops, let me move some things around here first. Get a little more room in here. Okay. What we learned is that the quadratic formula is negative b plus or minus the square root of b squared minus 4 times ac over 2a. And the a and the b and the c came from the leading coefficients of x squared, x, and the constant term. The discriminant is what is inside the square root, or b squared minus 4ac. And what we have found is that this can either be 0, it could be positive, it could be negative, and sometimes it can be a perfect square if it's positive. So let's take a look at some answers here, because if we find that the discriminant is 0, so we get done with our answer and we have 0 in the square root, which is 0, that means we're going to have one rational solution. And if we have the square root being positive in a perfect square, like the square root of 25 or the square root of 36 or any kind of rootable number here, this is going to tell us we're going to have two rational answers. Now, what if it happens to be a positive answer inside the radical, but it's not a perfect square? Like, let's say it's the square root of 12. Well, that means we're going to have two irrational answers because you're going to have a square root as part of it. Now, what happens if this is negative, whether it's rational or irrational? Well, no matter what the problem is, whether it's the square root of a negative rootable number, or if it's the square root of a negative non-rootable number, you're going to have two imaginary complex solutions. So you're going to have I in those solutions because you're going to have to factor out. You're going to have to use the product rule to have the square root of negative 1 before you work with the other numbers inside, be it 25 or 12. So let's go apply that a little bit, and just by looking at problems 1 through 4 here, we're going to term the type and also the number of these solutions. So we're going to figure out how many solutions they have, either they have 1 or 2 solutions, and also figure out if they are rational or if they're imaginary answers. Alright, so in this case, since this is set equal to 0, a is equal to 1, b is equal to 0, and c is equal to 7. Now we're only computing the discriminant, so we're only going to be looking in these problems at b squared minus 4 times ac for each of these problems here. So we're going to go 0 squared minus 4 times a times c. I'm using parentheses because that just makes it a little easier if we had negatives. This is going to give me 0 minus 28, which gives me negative 28. From the chart above, since this is a negative answer, and that means we would have a negative square root of 28, this means we're going to have two imaginary solutions. Because we're going to have a plus or minus an I in the answer. Even though we can factor out a 4 here and get 2 square roots of 7, this is going to give us two imaginary answers with plus or minus 2 square roots of 7i. Now, in problem 2, we're going to have a, b, and c. The a is 4, the b is negative 12, and the c is 9. Now we're going to plug this into my b squared minus 4ac. Careful to use the parentheses here because here we have some negatives. Make sure that's a minus, not a negative 4. It's a minus 4 times a times c. If I compute all this out, I get 144 minus 144, which gives me 0. And the square root of 0 is 0. That means we're going to have plus or minus 0. This way we're going to have one rational solution to this problem. Okay, for problem number 3, our a is going to be equal to 10, our b is going to be equal to negative 1, and c is going to be equal to negative 2. Again, be very careful when plugging these in. Negative 1 squared minus 4 times 10 times negative 2. Again, this should be negative 1 in parentheses squared minus, not negative 4, times 10 times negative 2. If you do that correctly, you get an answer of 81. And since the square root of 81 is equal to 9, therefore we're going to have two rational solutions. And we're going to have two rational solutions because the square root of 81 was a perfectly rootable number. For number 4, we have to change the format a little bit to 5x squared minus 48x equals 0. You got to move that 48 over to the other side. Here my a is equal to 5, my b is equal to negative 48, and my c is equal to 0. Alright, so what we have here then is we're going to have the negative 48 squared right there minus 4 times 5 times 0. Now, negative 4 times 5 times 0 just leaves us with negative 48 squared, which is going to be 2,304. But this, since this was our only thing left, is actually rootable back down to 48 again. So therefore, since this, like problem number 3, was a rootable number, we're going to have two rational answers, because our quadratic formula is going to have negative b plus or minus 48 divided by 2a, or 2 times 5 in this case. So we're going to have two rational answers in this situation. Alright, let's move to the second page. Now this is going to be kind of interesting because we're starting out with where this hits the ground, or we're actually starting out with where the quadratic equation has these numbers as solutions. Can we work backwards and actually find the correct answers? And the answer is yes. Now to just quickly sketch here, imagine that you had a quadratic graph intersect at negative 2 and positive 8. Now assuming that x is positive, we're going to have, or x squared is positive, we're going to have a parabola that looks like this and intersects at negative 2 and 8. So the question is, how do we build up an equation like x squared plus 2, or x squared plus ax squared plus bx plus c? How do we work up an equation like this and have it actually work out? Well, here's how we do it. Since our solution is negative 2 and 8, we have to work backwards as the solution is going to be fit into this equation. 8x minus h and x minus k is equal to 0. We're going to plug our negative 2 and 8 into these equations here. Now h and k are the intersections, or the roots of the equation, where it hits the x-axis. So this becomes x minus negative 2 and x minus 8 equals 0. Now to simplify this a little bit, this is going to be x plus 2 and this is going to be x minus 8 equals 0. Now all we need to do is FOIL to find my answer. So x times x is x squared. X times negative 8 is negative 8x. 2 times x is 2x. And 2 times negative 8 is negative 16 equals 0. Simplify the middle terms. X squared minus 6x minus 16 equals 0. This equation is my new quadratic that will give me these two answers. And we didn't do anything else fancy. We just said, well, my x squared is going to be positive, so we didn't have to worry about this being a frown. It's a smile. 6. We're going to follow the same format. We're going to take our negative 2 and plug it into our x minus h and x minus k format. So if you've kind of noticed that it's going to be the opposite of what you started with, then that's actually a good recognition. You'll notice that the negative 2 turned positive and the 5 turned negative because the format is x minus h and x minus k. So then we do our FOIL. So we're going to have x squared minus 5x plus 2x minus 10 equals 0. That means it's x squared minus 3x minus 10 equals 0, and that's the quadratic that will give me the two solutions of negative 2 and 5. The problems get progressively more difficult as we deal with numbers that aren't, well, whole numbers. Take a look at this example. Here we have 1/2 and 1/3 being where the quadratic hits the x-axis at these 2 points. Well, that's going to leave me with x minus 1/2 and then x minus 1/3 equals 0. So let's do our FOIL. X squared minus 1/3 x minus 1/2 x, and then negative 1/2 times negative 1/3 is positive 1/6 equals 0. Now, what we should do here, as it says in the original problem up above, is to clear the denominators. Let's combine these middle two terms here before we do that. So 1/3 minus 1/2. Now, if you're going to get a common denominator between a third and a half, luckily it's going to be a sixth. So this is going to be 2/6, since I'm multiplying the top and bottom by a 1, which is 2 over 2. And this is going to be 3/6, which means I'm multiplying the top and bottom by 1, which is 3 over 3. Negative 2/6 and negative 3/6 is negative 5/6 x plus 1/6 equals 0. Now we're going to clear the denominator, which is multiplying both sides by 6. This is not raising it to the 6th power, it just means multiplies everything by 6. So this is going to be 6x squared. 5/6 times 6th, the 6 do simplify here, and that makes minus 5x. 1/6 times 6, the 6's will simplify, which makes 1. 0 times 6 is 0. So this is your cleared fraction. Everything got multiplied by 6, got 6 times bigger, and then this, if we did our factoring from the very beginning like we did in Chapter 5, this would give us what we need, which is our answer of 1/2 and 1/3 for when it crosses. Here's one that's even stranger. This one calls back to what we did in the last section. In the last section in Chapter 7, we looked at FOILing using square roots. So x times x is x squared. X times the plus square root of 7 is square root of 7x. This is multiplied by the square root of 7. This is minus square root of 7x. And then this final one here is the negative square root of 49 equals 0. These two terms simplify, so this makes x squared minus 7. And x squared minus 7 equals 0 will factor into these two problems right here if you solve the problem. Okay, we've got another two problems to do to find our roots here. We've got our roots of 3i and negative 3i. So what we will do is plug this into our equation, which is x minus h and x minus negative k there. So that's plus 3i equals 0. Okay, x times x, x squared. X times 3i is positive 3xi. And negative 3i times x is negative 3xi, and these will be simplified out. But look at this. We've got negative 3 times positive 3, so this is negative 9i squared equals 0, because I times I is I squared. These two simplify out, so x squared is positive 9, because this is going to be negative 9 times negative 1, and then that's going to be equal to 0. And there's my quadratic. Now, this is a part of the worksheet that got cut off, and this should be fixed by maybe a semester or two later, but this should have two answers, which is x minus the square root of 10, or sorry, 2 minus the square root of 10, and 2 plus the square root of 10. So let's plug this into my formula. This is x minus parentheses 2 minus square root of 10. All right, and then this is going to be x minus parentheses 2 plus the square root of 10, parentheses. Now we have to simplify this a little bit. This is going to be x minus 2 plus the square root of 10. That's in the first parenthesis. Notice how the parentheses are gone now that I've distributed my negative there. And I'm going to distribute my negative here as well. X minus 2 minus the square root of 10. Now, instead of having a binomial FOIL problem like we did in problems 5 through 9, now we have two trinomials. And so we will slowly take our time to distribute the first term by each of these terms here, here, and here. So this is going to be x squared minus 2x minus x square root of 10. Now I'm going to change colors here so you see how I'm doing the distribution. Now I'm going to take my negative 2 and distribute that here, here, and here. So negative 2 times negative 2 is positive 4. Negative 2 times, whoop, I'm sorry, I went out of order here. Negative 2 times x is negative 2x. Alright, negative 2 times negative 2 is positive 4. Luckily, these are all commutative, and negative 2 times negative square root of 10 is going to be positive 2 square root of 10. Alright, I'm going to change color one more time here. I'm going to change to green, and I'm going to work with this one. Let's see here. I'm going to have a positive x square root of 10. I'm going to have a negative 2 square root of 10. And I'm going to have in here a negative square root of 100. Now the negative square root of 100 is just like saying negative 10. So I did simplify that a little bit, because 10 times 10 is 100 under the radical, and that simplifies to itself, which is 10. Now I'm going to choose another color. This is going to be another color to show how I'm going to do some simplification. First of all, look for opposites. There are some things that will simplify out. For example, this 2 square root of 10 and minus 2 square root of 10. Those simplify out. Also, you'll see that there is a negative x square root of 10 and another x square root of 10, and those simplify out, leaving me with x squared, there's no other x squareds to combine, minus x and minus 2x and minus 2x, which makes minus 4x, and then we have a plus 4 and a negative 10, which makes a negative 6 equals 0. This, if I use my quadratic formula, will give me the answers written up above for problem 10. Woo, that was a little bit of algebra workout, wasn't it? Alright, let's move to our final two problems here, and you'll notice that in problem 11 that there are 3 answers here. And the reason why there are 3 answers is this is going to make a trinomial. Now watch what happens here. With our 3 answers here, this is going to be x, whoops, here, my pen, come on, work, x minus negative 5, or x plus 5. This is x minus 0, which is just x, and this is x minus 2. Now if I rewrite these, I'm going to have x times a quantity of x minus 2 and x plus 5. This means I can FOIL this and then multiply by x at the end, making this a trinomial with a degree of 3. So this is going to be x squared plus 5x minus 2x minus 10, or x squared plus 3x minus 10 equals 0. But you'll notice that there's an x pretty much still I wrote that in the wrong place. There's still an x hanging out in the front of this here. So what I'm going to do is combine this at the end. X cubed plus 3x squared minus 10x equals 0. And here is my trinomial, but this is a degree 3, which means it can have up to 3 real solutions. So there it is. There's your 3 real solutions. If you factor out an x and then did your factoring, you get back to these 3 answers. Now, when I state that negative 5 is the only solution and this is a quadratic, you can't just say, alright, x plus 5 and be done. You have to write x plus 5 twice. Now the reason why is this gives it a bend in the curve. If you do your FOIL, you'll get x squared plus 10x plus 25 equals 0. But I think what's neat about that is we should take a look at this on the graph. Now, you make sure to copy this down or pause the YouTube video here before I switch to my graphing calculator. So x squared plus 10x plus 25, if I look at that, it's going to be like this. Per x squared plus 10x plus 25, and then hit graph, it's going to intersect at negative 5 and only negative 5. And if I didn't put the second set of parentheses, if I just went x plus 5, like some of you might have thought, then it wouldn't be a quadratic. It would be a linear graph that intersects at that only solution. But by adding the second x plus 5, and thus making it equal to x squared plus 10x plus 25, you get the curve that you see here. Alright, well thank you for watching.